welcome. Hello, everybody, to week 2 and the rest of chapter 1, intro psych. Okay, with that, let me just expand that and pull up my screen. Bring this forward. And okay, very good. So we will continue our discussion about the science of psychology, some issues that currently come up in the area of studying human behavior. But before we do that, I just wanted to remind you all that 5% of the Psych 1000 grade does go to participating in a study. Okay, there is that alternate assignment of writing 4 one-page, reading 4 articles and then doing a one-page report on each of those articles. And if you want to do the alternate because you don't want to be a psychology subject, that's fine. Just let me know and I will set you up for that assignment. Okay, which will be due near the end of the semester. And also similarly, the participating in a study is due by the end of the semester, so you have plenty of time, don't we? So here's how you get involved. Okay, check your Blackboard page for our class. Okay, there will be a couple of attachments under course contents. Okay, go to course contents and you should see something labeled study subject participation, something like that. Okay, and in that folder you'll see 2 attachments. Read those attachments. Okay, they don't take too long. There are one's a few pages, one's a couple pages, and it kind of walks you through the whole process. Okay, sets it out very easily. Okay, now part of the process is you are setting up a Sona account. Okay, that Sona is the online website which manages subject pools. Okay, so you would set up your Sona account on http hpu.sona-systems.com. Alrighty, and click on New Participant. Click here on the left of the screen. When you sign up, this is really important. Okay, when you sign up for an account, use your username. That is your HPU email address. Okay, whatever, jsmith@my.hpu.edu. Okay, don't use your Gmail, don't use your Yahoo. If you do, you're gonna run into problems. Okay, so sign up using your HPU email address. Okay, now if you have questions regarding a study, please ask the researchers, not the Sona administrator. Okay, we do have an HPU faculty member who administrates what goes on Sona. That's Professor Doug Hall. Alrighty, don't go to him if you have questions about the study. Okay, if you have, let's say you participate in a study, the study asked you some questions, and you're kind of wondering, hey, why are they asking me about that stuff? Okay, each study should have an identified researcher or researchers to whom you should make that inquiry. Okay. Now, after going through all this, if you run into any problems or you have any questions, feel free to contact me. If it's a larger Sona, not a study, but a larger Sona account issue, you can contact the administrator, Doug Hall. That's D for, I think it's, I'm sorry, he should probably be under W for William, H as in hotel, A as in alpha, L as in Lima, L as in Lima at hpu.edu. Okay, he should be able to assist you. Okay, if you have any questions about getting credit for this for the course, feel free to ask me. Okay, now the way this kind of works too is after you do each study, you get a credit. Alrighty, you need to make up to 6 credits. Alrighty, so that could be 6 online studies or 5 online studies and 2 face-to-face kind of one. 5 online studies and a single face-to-face study. Okay, I mean, no, the 4, scratch all of that. 4 online studies are 4 points, and then 1 in-person study for 2 points. Okay, there we go. All right, I got my brain together there, sort of. All righty. When you do that, it's going to be on Sona, and then at the end of the semester, I'm going to jump onto Sona and see who's made up their credits for the study portion of the semester. Okay, so if you have any questions along the way, feel free to ask. And otherwise, that should take care of that for the 5% portion of the grade, which involves participating as a study, in a study, not as a study, in a study. Okay. Now, let's continue with our discussion about psychology and nature versus nurture. Okay. This is certainly a recurring issue in many disciplines, but certainly in psychology. Yeah, when you're talking about mental disorders, right, schizophrenia, depression, or IQ intelligence, or male-female differences in assertive behavior, in sexual behavior. How much of it is nature? How much of it is nurture? Yeah, or either or. Well, first of all, as you may recall from our last discussion, it's never either or. Alrighty, it's almost always an interaction of the two. Okay. So when it comes to a lot of human behavior, the explanation and understanding of human behavior, it's usually an interaction of the two. Yeah. Now, if it's not either or, the other very popular question is how much? Yeah. Is it 80% this, 20% that? And Anastasia, a big figure in psychological testing in the 20th century, proposed that even that question is illogical. Yeah, something like Mr. Spock. Much like, and she analogized to the question of either or, that in that the attempt to say how much of each also disregards the reality that the two interact, okay, and how they interact, and that they're in continual interaction. Alrighty. So asking how much of each is kind of the same as either or. Okay, which one? Now, the reality is that for a number of phenomena, some things will be more environmentally driven and some will be more biologically driven. Yeah, but to get a very specific number of how much is probably elusive in most cases. Alrighty. Now, starting our discussion about nature versus nurture, yeah, we start with the cell. We start operating from the molecular level, not the atomic level, but the molecular level. Yeah. So here we invoke the disciplines of chemistry and particularly biology. And on the molecular level, yeah, we're talking about the cell or DNA. Yeah. And as you may recall from prior classes in grade school and high school, yeah, the cell, in each of the cells, there are 46 chromosomes, yeah, 23 or 23 pairs. Okay, we get a set of 23 from mom and a set of 23 from dad. Alrighty, and right now it's female contribution, male contribution. In the not so distant future, maybe even foreseeable future, we may have pairings, mom and mom or dad and dad. It's theoretically possible. We just don't have the technology to do that. But right now it is from a female donor and from a male donor. Yeah? And a chromosome is a molecule of deoxyribonucleic acid. Yeah. And what a chromosome and a gene is a discrete segment of a chromosome. Alrighty, so 23 pairs of chromosomes. A chromosome is a molecule of DNA, yeah? And a gene is a discrete segment of a chromosome, okay, kind of breaking it down here, yeah? And what a gene does, right, you recall there are 4 types of genes, we won't get into that right now. They lay out, right, instructions. It's a code, it's information, yeah? You can analogize it to computer code or programming. And like a computer code or programming, yeah, instead of the code being based on ones and zeros, it's based on, right, 4 genetic codes, okay? What is it? Thymine, adenine, guanine, and cytosine, alrighty? And based on the series of codes, right, so we have just hundreds and hundreds of these sequences of A, G, C, and T, right? It might be T, T, C, A, down the DNA, right? Based on that sequence, right? Just like a computer code, right? It directs the body to produce hundreds of different syntheses of protein, okay? So, and different synthetic structures or protein construction will lead to the construction of different processes, different, will lead to the construction of different organs and so on, and also set into motion different processes. Yeah? Now, so genes lead to the synthesis of hundreds of different kinds of proteins. Okay, and it's essentially the body's building blocks. For those of you who may not recognize this, this is an image of the movie Gattaca. Yeah, it's a sci-fi film. I think it was from 2001. It's kind of old now, but it's a great movie. It hasn't dated itself. Yeah, you can watch it and it feels fairly current. But it's a story. The premise concerns the issue of what we're talking about right here, genetics, and specifically, right, parents being able to select a genetic code of their newborns. Alrighty, the idea being that by doing this, right, we can select out problems, yeah, or select in, right, strengths. So take out problems and weaknesses, bring in assets and strengths. That's the idea. So you can kind of basically, just like a computer code, right? Set up a good computer code, get a great program or video game. With the setting up the genetic code, right? That this will set out the structure, the foundation, right? The program for the kind of child you want, all righty? Now, this is kind of a thought-provoking notion, kind of a very provocative idea, and an interesting ethical kind of moral issue. Yeah? And here's the issue: should parents have the ability to do that? Yeah, and if so, why so? And if not, why not? Yeah? Perhaps we'll have this discussion in our Zoom meeting. Yeah, but I'll just leave that with you for now. Yeah, what are the pros and cons of it? I think this might be a great debate topic. Yeah, of genetically being able to determine your child's code. Yeah. Now, it may seem obvious at first what the answer is, right? The answer is, heck yeah, if you can, take out, let's say, the genetic code that would have led to the development of, say, cancer, yeah, or a heart condition, or let's say major depression or schizophrenia. It seems like a no-brainer that you edit away those kinds of potential problems. Yeah. But one of the things you might want to ask yourself when you edit out, especially things such as related to the human experience, like emotions, what other things might be going with that you toss into the trash, so to speak. Yeah, instead of the trash on your computer, the DNA kind of trash, so to speak. Yeah. Are there things that are ostensibly weaknesses, yeah, or deficits, which actually on the flip side are strengths? Yeah? So what if you were to take out the code? If we don't have this yet, one day we probably will, right? We understand the code for violent behavior, yeah, for those who commit assaults and so on. So you clip, you take that out, What could be the ramifications of that? Do you take out one's potential to justifiably fight, yeah, defend oneself, and so on? Yeah, well, I leave that up to you. Let's move on. Evolutionary psychology. So what is evolutionary psychology? Yeah. Well, as you can surmise, it's the application of evolutionary theory to psychology. Understanding human behavior from an evolutionary perspective. Yeah. Now, I'm not going to revisit evolutionary theory. That's beyond the scope of this course, yeah, and certainly this lecture. But you know the general idea with evolutionary theory. Yeah, it's the idea that we'll see certain behaviors or physical traits increase if it's adaptive to the environment. That's all evolutionary really, I don't want to oversimplify, but really essentially proposes. Yeah, if there's a fit between the organism, an adaptive fit, right? If it adapts to the environment, yeah. If there's a fit and the organism is able to adapt to that, to the environment, we're going to see more of that organism, right? It's more likely to reproduce, and we're going to see more of its behavioral features and or physical features that was a fit with the environment. Yeah, you know, the old thing about the type of moth, which is dark versus lighter, and which one would, you know, in certain urban areas because of the industrialization and the smoke that was coming out from the chimneys from the factories, that certain moths were able to hide better than others, and those that fit with the color of the smog that would you know, attach itself to the walls, that those moths were more likely, if their coloring were similar to the smog or dust that attached to the walls of buildings, that it was more likely to not be seen and then reproduce, whereas the moths with different coloring that didn't fit the the dirt and so on and smoke and that attached to the walls were less likely. If it didn't fit, they'd be more likely to be seen by birds or predators, and more likely to die, less likely to be prevalent. And evolutionary theory, right? By the way, when you hear, in most cases, yeah, about theories like a theory of relativity, evolutionary theory, yeah, gravitational theory, yeah. Colloquially, people think of the word theory as question, yeah, or tentative idea. Okay. Well, there is an actual tentative quality to theory, so we'll get to that to a moment, in a moment. We're not just talking about a passing question or a passing idea or passing speculation. Yeah. Theory, when used scientifically, like in the examples I just gave, really refers to a framework. Yeah. A well-established framework for understanding phenomena. Yeah. And that's what evolutionary theory is. It's a framework which has held up to different findings in research. Yeah, most of the research supports it. Now, a scientific theory will also is um, a scientific theory, right? Is a framework for understanding things. And when you hear that term, we're talking about an idea that is supported by research. Now, here's an important thing that sometimes confuses people in the general public. What about conflicting findings? Yeah, well, what about them? Well, first of all, do they exist? Sure, they exist. They exist for many things which are well established, right? Like climate change is well established, right? And the theory behind climate change, right, that it exists and that it's been a large part of function of a human intervention or actions, yeah, is well founded. Now, does that mean there are no contrary findings? Rubbish, of course there are some contrary findings. Same thing as with the theory concerning the relationship between smoking, right, and the nicotine, and its relation to cancer. Right? Are there some studies that contradict that relationship? Sure, there are. Yeah, there's bound to be. Yeah, where a theory is well supported is when most of the research seems to be consistent with that framework or understanding. Yeah, but there's bound to be some studies that contradict the um, the body of research. Okay? What's important when you see that, yeah, for your particular area of expertise, whatever you pursue, be it biology, chemistry, psychology, and so on, is to understand why those studies may contradict the the wealth of research or the majority of the studies. Okay, it isn't just to go with the majority. I mean, you know, a scientific perspective is against blind adherence to the mob. All righty, it's about looking and counting, right? And if the majority of the studies support evolutionary theory, climate change, the relation between smoking and getting cancer, then you operate from that. And you understand why some findings are inconsistent. And it behooves one, particularly if that's your area, to understand why studies may contradict each other. Yeah. And how do you do that? You understand how the studies were actually conducted, which in some instances might behoove you or require you to read those studies and try to see, okay, why is there a disconnect? Okay. And usually, right, you can find why there may be a disconnect and make sense of that. Okay, not always, but usually. All righty. And also, as an aside, when you know, so again, going back to the majority, you don't just adhere because most to what the majority of studies say because the majority says it or the mob rules. I mean, you know, as an aside, here's a little disclaimer. Right? Life is so complex, and there's so many things you need to know that sometimes you do have to turn to experts or reliable sources. Yeah, because you don't have the time to read the research on every single thing that's out there. All right, you just to be focused. It behooves you to know some of the more important studies for your area, whether you're an engineer, or chemist, or what have you. There's just no way you'll be able to read most of the studies in most areas. Yeah, and certainly not all the studies. Um, but it's important to understand how the research was done and so on. Okay. Also, getting back to kind of the burden of proof. Yeah, it's not a legal idea, but it is a professional practice that when a study contradicts the majority of studies, the burden is on the researcher or researchers who did the study, which contradicts the majority, to try to make sense of that. Yeah, you just can't say, "Oh, we contradicted, so the rest of it is all BS, right, or wrong, and we're right." No, the burden is on you because all these folks supported or explained their studies. Now you got to explain why yours is different from theirs, right? Because their studies were reviewed by in academic journals by a jury of their peers, on a panel that reviews their studies. And by the way, when it comes to peer-reviewed academic journals, yeah, most in most cases, only if you're lucky, there's a 1 out of 10 chance of getting published. Yeah, meaning 90% of studies that are submitted to journals don't get published. Yeah, it's only about 10%. Okay, and why? Because it's really tough. You got to do good research, and if by the determination of your peers in your field, you haven't met that, you're out of there. All righty, that was a lot about a theory, but I think it's an important one before we continue. So that's the idea of evolutionary theory, right? So we'll see more. The reason why you may see more of something is no small reason. It probably was adaptive to the environment. And that relates to many phenomena in different species. Yeah, relates to a lot of different non-animal phenomena as well too, but that's beyond the scope of this course, like in economics and so on. But certainly in human behavior, if we see a certain physical and or behavioral trait, right, present amongst us now, it probably had some adaptive function. All righty, so that's the idea. Now on the origin of species, right, which was Darwin's hallmark publication book, which laid out his theory. All righty. The idea was that genetic material is passed down through successive generations, as described just a moment ago, if one's features fit with the environment. And that's all it is. It's not because it's good or bad. The bottom line is what's going on in the environment that allows one to thrive or survive. Also, there must be variation in within a species, right? And that variation, the greater the variation, the more likely this species survives, right? Because the more variation you have within a species, when things changes when there are changes in the environment, whatever the environment may be, right? Whether temperature, what types of behaviors are reinforced. Yeah, we see where you get more resources, right? Might vary, right? Certain hunting skills, certain flight abilities, right? Certain with humans, certain intellectual abilities, right? Might gain greater access to resources. That's more, the species is more likely to continue, right? Maybe in a slightly different form. Now, part of the reason why evolutionary theory is hard for some people to appreciate is the fact that these changes in a species or among species, right, with the environment, whatever that environment may be, doesn't happen overnight. Yeah, if it happened overnight, we go, oh, there we go. There's evolution at work. It never works that way. Yeah, it works over hundreds and thousands of years and hundreds and thousands of generations. Yeah, so it's very hard to see, very subtle. Yeah, but it happens. Yeah, we can see across recorded human history and across the recorded history of other species, right, and other earth sciences, right, how species have changed over time. Okay. Now, the process by which certain traits and or behaviors fit, and then we see, fit with the environment, which allows that particular behavior trait to garner or gain the particular species resources, that kind of fit or connection is what's referred to as selection. Okay, so it's a selection process. Now, it's not God selecting or a committee selecting. Yeah, it's just chance. Chance is making, and that's what's kind of scary about these things. Yeah, it's the chance combination of whatever the organism has in their DNA with the larger environment. Okay. Now, chance can occur in two major ways, right? There's artificial selection, natural selection, and artificial. Now, natural is the one we often think of with evolutionary theory. Okay, there's some change in the environment, and hence, a certain species now is able to hunt better or survive the winter better, and then they're more likely to continue living, right? And again, this never happens over one season, but over hundreds, if not thousands, of generations. The other kind of selection process is artificial, meaning there kind of is a committee making a decision, well, not an official committee, but people, right, deciding to breed a certain type of wolf, right, a very docile, cute wolf, and that's what we did. Yeah, and through artificial selection, dogs are created, and all the different varieties of dogs, right? They weren't bulldogs all the time, nor cockapoos, and all those different kinds of dogs. I mean, you didn't see bulldogs and cockapoos running through jungles, the beginning of the species of wolves, all righty? But what it looks like happened very early on is that some wolves, right, did actually hang out with Homo sapiens. Right, not all wolves, right? But we see, right, evidence of that, archaeological evidence of certain wolves, their bones, right, their remains, right, near human remains, right, which tells us that humans, right, did, take in certain docile wolves. They acquired them as pets. Alrighty, and then from that point, started finding, certain features of these docile, friendly wolves, and seeing certain features that seem particularly attractive in terms of fur or facial features, and then they reproduce, and then early people kind of realized that you could do that, right? So you simply get two of the docile wolves that have the kind of fur you find attractive and make sure that they kind of hang out and then reproduce. And then you get more of that curly fur that you find so cute on your docile wolf. Alrighty, but again, that never happens overnight, right? It's a gradual process. We'll skip these two questions. Okay, we see this manifested in a lot of ways in human behavior. For example, with human sexuality, yeah, are there differences? Has the social, psychological, and human sexuality research found differences in male, female? And we're going to stick mostly right now with male and female heterosexual behavior. Not to say that homosexual, bisexual behavior isn't important or as valuable. It just hasn't been researched nearly as much as it should. So we have mostly the heterosexual kind of differences to focus in on. But are there differences between males and females in terms of sexual behavior? Yes. Okay. Not that all males don't want to perpetuate a stereotype and suggest that all males act a certain way and all females act a certain way. But, in terms of probability, is it more likely for a male to act a certain way most of the time, and the likelihood that a female is going to act in a certain way most of the time? Yeah, we find that, and we also find that cross-culturally. Some of the behaviors, differences in sexual behavior we find across time. Well, certainly across time, but also across culture. Now, what are some of the differences, very common ones, we find in terms of human sexual behavior between males and females? Yeah. Well, one thing is the idea of males having more than one sexual partner. Okay, they tend to have a higher number of partners than women. Okay? Not that women don't have multiple sexual partners; they certainly can enjoy that just as much as men. But generally, cross-culturally, universally, we find it more likely that men are going to have a higher number of partners. That also men are more likely. There's not this darker side of things, more likely to control their partners. Okay, and we'll get to that in a moment why that's the case. And control by doing things such as, well, certainly domestic violence is an example, right? If the partner talks with other people, socializes with others, right? Males demonstrate greater prevalence of domestic violence, being the perpetrators of domestic violence in females. Now, as an aside, this is a great example of how there's variation, right? Because there are females who who are perpetrators of domestic violence too. Yeah. But what is not true, it's not true to say they do it up to at the same frequency. Yeah, that's absolutely not true, and you're not going to find that, and you rarely find it where it's flipped. Yeah, there may be one or two remote cultures, in tribal cultures where it is flipped, but it's rare. Okay, females also tend to be more. Again, it's not black and white, but tend to be more selective in who they choose as a sexual partner. Okay, we'll kind of touch on that in a moment, why that's the case. And usually in many cultures, right, Asian, African, European, we see that it's very often females who do set the criteria for dating and mating, yeah, for what makes for a bond, yeah, which may lead to marriage. All righty, and why is that the case? Well, we'll see. All righty. All righty. Now, here, let's get back to evolutionary theory and how it probably explains a lot of these behaviors. Okay, evolutionary theory proposes that there are certain pressures on the species to reproduce or to survive and reproduce, same thing. Yeah, and when we're talking about Homo sapiens, yeah, arguably the pressures are greater, yeah, on men. And we'll talk about pressures, meaning pressures to succeed, to find a mate and reproduce, than with females. And let me elaborate on that. I'm not saying it's a great deal for women either. They certainly have their pressures as well. Okay, but what do we mean by that? Okay, we're talking about how when there's greater pressure on the male of the species, meaning that there's greater pressure effect on male behavior than on female behavior. Although there certainly are some ways in which the fit between genes and the environment affect female behavior too. So get to it, Tashima, what the hell are you talking about? Okay, well, let's talk about parental investment theory. This was proposed by Robert Trivers, and what's proposed is that the genetic contribution of males, yeah, if you were to put apply an economic analysis, yeah, to reproduction, yeah, and to the actual genetic material, right? The genetic material for males is sperm, and the genetic material for females are eggs, okay? The idea that Trivers proposes from an evolutionary perspective is that sperm is and also from an economic perspective, is cheap, okay? And, excuse me, eggs are valuable, okay? Now, why is that the case? Well, think about it, right? With economics, if there's something that's highly available, right, you have a hard time putting very big price tag on it. Yeah, like let's just say a cheeseburger versus filet mignon, right? Between the cheeseburger, there's tons of those, right? McDonald's sells billions, if not trillions, at this point, right? So cheeseburger is going to be fairly cheap, whereas filet mignon is going to be much more expensive because it's harder to make and there'll be less of it. Okay, same thing with eggs and sperm. Okay, don't mean to sound gross with that, but sperm you can spread widely because it's very cheap. Alrighty, men make it all the time, and can release it. It varies depending on the age of the person and other biological predispositions, but, can release sperm at least once a day, if not more, and certainly, and certainly more. Whereas eggs, right, are typically, viable eggs are typically produced, right, maybe a couple or a few once a month. Okay, so there's way fewer eggs than there are sperm, right? So from a evolutionary biological framework, eggs are valuable, right? Whereas sperm is cheap. So because of that, right, it behooves the male, right, because he's got something not so valuable and the woman has something valuable, right? The pressure is on him, right, to be able to spread his material, to sell it, so to speak. So that's the environmental pressure. Yeah, if the male wants to see more of himself or his family line, right, the pressure on him is to find someone who has that valuable genetic material, because it can't just be sperm, right? In order to reproduce, he needs a female, right, who has the valuable genetic material that she produces once a month, right? And even for females, right? For males, it'll be right about puberty until gosh knows how old, right? Uh, but there's more data, right, that's come out that sperm is less viable when men are 65 and older, but it's still, right, theoretically possible to reproduce even into your 80s, right? Although the sperm may be less viable, may have more genetic mutations and problems and so on. Whereas the female, right, even the period, not only is she limited to releasing eggs once a month, right? Even that period of time where she is an egg producer is limited from puberty to about, in her 40s, but some well into their 50s and so on, right? But that's why you so rarely hear about a woman reproducing, right, being pregnant in her 50s, because just like with males and the sperm, right? There may be eggs, but but even those eggs become less viable. Yeah, right. And then certainly when she hits menopause, typically by her late 50s or early 60s, she won't be producing any more eggs, right? So the pressure is on, as I said, on the male. There's less pressure on the female, but now she's more in a power position, so to speak, with her, expensive Rolls Royce or filet mignon to kind of make the calls as to, okay, who is she going to allow to mix her genetic material with their genetic material, right? And that kind of gets back to what we said before, right? So if your material, you have a cheeseburger, it behooves you, right, to try to sell it to as many people as possible so that the cheeseburger gets around, so to speak. You also, once you find, someone who will reproduce with you, right, males are more likely to control their partners, right? To want to really be careful about who they're, females get jealous too. I'm not trying to say it's only a male phenomenon to get jealous, but to control one's partner, yeah, it's far more often a male phenomenon. I mean, females may control in other ways, but to really be sure they know who who their partner's relating with, the pressure is greater on males. Why? Because maternity is always certain, paternity is not, right? When the baby comes out of the woman, we know it's the woman's baby. Okay, it's not a card trick. Alrighty. But for the male, right, he doesn't really know, right? He kind of can presume, right? But just because he was having intercourse with a woman, she could have been having intercourse with who knows how many people, right? He doesn't know absolutely. Alrighty. So how does a male increase the chances of his knowing or having certainty? Controlling the female. And sadly, if we look cross-culturally and across time, we can see a number of ways in which males do that and have done that. Yeah. And again, because females, have this valuable material, right? They can have more of an influence. They can be more selective as to who their partner will be, yeah, and set the criteria in terms of, is he tall, is he smart, does he do drugs, all that kind of stuff. Okay, so this has led to a lot of differences, probably contributed, right? Not Absolutely, but probably contributed to a lot of differences we see in sexual behavior between men and women, where, as a general matter, usually men are more promiscuous. They're more likely to guard their mates. Females are more likely to assess a mate's fitness, right? They're more likely to be concerned about the partner's age, his dominance in social circumstances related to his ability to access resources. Um, and his ability to protect her, to protect young, and so on. All righty. And male. Okay. Now, also for males, just regarding the male selection criteria, right? Because it behooves a male to, um, have as many purchases of his cheeseburger as possible, right? Those males who are more likely to reproduce are those who get aroused easier. Yeah, there's probably a now, when it comes to sexual arousal, there's obviously a lot of a variation among people. However, in our species, right, those males who get aroused easier are more likely to have the physiological energy and drive to spread their genetic material, so to speak. So that's why males compared to females, right, because males have the pressure to sell their cheaper material, the cheeseburger around, right? It behooves them to be more easily aroused. Right? That's why between males and females, I'm not saying females don't get sexual, they certainly do and can enjoy sex just as much, have the subjective enjoyment of sex just as much as males. But in terms of arousal, most females do describe taking longer to get aroused than males. With males, sometimes a cool breeze will do the trick, right? And that's no surprise. It's not just a joke. I mean, it's generally true, right? It doesn't take nearly as much. Sometimes you'll just take one photograph and bing, guys are ready for action, and that's just not something that's been cultivated by the environment or the media. It's a physiological difference, yeah, and because of that, right? Because a male will be more is easier to arouse, right? That's why there's a male will be more likely to be responsive to the woman's physical attractiveness. Now, again, don't get me wrong, women have their criteria for attractiveness, like strength, height, all that kind of good stuff. Alrighty, but because males can be so easy aroused, that's kind of stimuli, right? Like physical attractiveness, being clean, looking as though you don't have any kind of disease, symmetry in the face, right, is more likely to be activated in males quicker and so on. And so males are more likely to glom onto those particular things that make that connection quicker. Alrighty, so just moving right along. What's the criticism, though, of an evolutionary theory framework, yeah, to human behavior? Yeah, and this can be argued as evolutionary theories apply to other things, okay? Certainly, one can argue that a lot of evolutionary thinking is kind of not so unlike the hindsight bias, right? Looking at things and then trying to think back, okay, well, where did that come from, right? What happened before? And then trying to paint a picture based on, one's looking at the past and go, oh, okay, well, that makes sense. And then kind of connecting the dots to what happens in the future, right? It depends on what dots you connect or you choose to connect. The other thing is that evolutionary theory can reasonably and arguably be used to perpetuate male-female stereotypes. Yeah, and again, what should be uh, kept in mind, a good scientist will keep in mind, is that we're talking about probabilities. Yeah, we're not talking about absolute differences. Alrighty, there's certainly a lot of variation within the male group and a lot of variation within the female group. Alrighty, and there are females who act far more like males and males who act far more like females. Alrighty. That said, this kind of framework can perpetuate that kind of stereotype. Yeah. The other thing is that it can really undercut and it shouldn't. And evolutionary theory, wouldn't do that. The proponents of Darwin, certainly his whole point was that it's an interaction between the organism with the environment. Yeah, so you shouldn't discount the environmental factors that contribute to the differences you might see in this example, human sexuality, yeah, between males and females. Um, so there's certainly an environmental component, and Darwin would subscribe to that. All righty. There are certainly cultural factors and the thing is, it's not either or, yes. But what is the interaction of the environment with the species, right, with the organism? And certainly cultural factors have a play. Cultural factors have a huge play in what we consider attractive and so on. Yeah, and not only culture but history. Yeah, in terms of body weight, certainly that's varied over time. Okay. We'll skip this. So what is behavior genetics? Okay, similar to what we've been talking up to now, it is the study of the relative power and limits of genetic environmental influences on behavior. Okay, so it's an attempt to examine that question of the interaction between genes and the environment. Yeah, the relative contribution of relative, right? Not exactly saying how much, but trying to come up with some evidence as to the nature of the interaction and how much. Alrighty, a lot of this kind of research is done by way of twin studies. Red Bull. Alrighty, and you're probably familiar with twin studies, yeah? They typically examine, and in psychology, they typically examine whether we see the manifestation of certain behaviors. Yeah, let's say depression, schizophrenia, assertiveness, musical ability, between monozygotic, identical versus dizygotic twins, non-identical. Yeah, dizygotic twins, right? Monozygotic twins are like our natural clones, right? Not completely, but as close as you can get, right? But the genetic mapping or the programming is essentially the same. Whereas dizygotic twins are about as similar as any other couple of siblings, okay? They just happen to be born at the same time. They each have a different programming, DNA mapping, all righty? So they're as similar as any pair of siblings, they're not identical. And the thing that's done in twin research is to see the correlation between monozygotic twins and compare it with dizygotic twins. Yeah, and if you see a higher correlation among monozygotic twins compared to dizygotic twins, it suggests a stronger contribution of genetic factors. And we see this in a number of psychological phenomena. First of all, extroversion, yeah, is higher among MZs versus DZs. Yeah, and we see that also across time developmentally. Yeah? Extroverted infants tend to be extroverted toddlers, children, adolescents, elderly people. Yeah, extroversion, introversion. Yeah, quiet, introverted people who like to, be alone most of the time. Not to be antisocial, but they just like chilling out with a book or listening to music. They don't have that strong desire to be in social groups like extroverts, right? Who'd rather always be hanging out with their crew. Do people still say crew? Friends and family, go to parties, and all that kind of stuff. That's the extrovert. Yeah, and similarly the introvert. Yeah, introverted toddler tends to be introverted senior citizen. Neuroticism, okay, being really nervous and anxious. Alrighty, constantly worrying about stuff. Right, people vary. Some are completely cool cats, and they rarely get anxious or bothered, and others tend to get bothered all the time. Right, so it's on a continuum. Alrighty, that's another one. MZs tend to be more similar to DZs. Yeah, we see variation among people. It suggests a greater contribution of genes when a strong contribution, not greater, but a strong contribution of genes in anxiety disorders. Okay. And even with other things such as different abilities, musical abilities, athletic abilities, certain personality traits, even some personality traits like conscientiousness. yeah, we see higher among MZs versus DZs, and even things such as interest. Yeah, so interest. Let's just say, what would be an example? Good interest. Interest in the arts. Yeah. That's probably certainly related in some way with personality and abilities. But yeah, even the kinds of stuff people are interested in watching or spending time or reading about and so on. Yeah. NZs are more similar than DZs. It's kind of wild, maybe frightening how much of, our musical ability and how quiet or how much of a party goer we are, and to what extent we're interested in world affairs or disinterested in what other people are doing is a function of biology, and it's certainly a part of it because obviously, we're functioning with a brain, uh, biological tissue, and a biological body. So clearly, a part of it, a big contribution is going to be what's transferred through that old genetic code. Okay. One of the things we typically find, though, are that MZs raised together tend to be more similar than MZs separated at birth. Yeah, which kind of tells us that there's an environmental contribution. That said, very often the MZs who are separated at birth still are more similar, right? The correlation in terms of their interests, abilities, and all that kind of good stuff, it still tends to be higher than the correlation between dizygotic, right, non-identical twins separated, which again kind of goes back to a biological contribution. The other way that behavioral genetics collects evidence is by way of adoption studies. Okay, so examining the correlations between adoptive versus biological parents, right, with their adoptive with the adopted child. Alrighty, so you have the sample of adopted children, right? Children went through the adoption process, who their biological parents gave them up for adoption, and then they were later adopted by their adoptive parent. Okay, and finding a correlation between the biological parent with the child on, say, intelligence, musical ability, neuroticism, extroversion, introversion, with all those scores, with the scores of the adoptive parents, with the uh, um, adoptee. Okay, the child is adopted. Those studies can get even more complex when you examine maybe if the adoptee, right, the adopted child had siblings, and if those siblings were in different households, or comparing that sibling, the adopted child, with their siblings who are the biological children of their adoptive parent, right? Their adoptive parent adopted them, but maybe their adoptive parent had their own biological children. So examining the correlate. So there's all this correlations between the adopted child and the biological children of their adoptive parent. And there's so many ways in which you can examine the potential co-relationship with different behaviors. Yeah. So with obviously the idea that the adopted child shares more biologically, but obviously with their biological parent. Alrighty. So what are some of the things that there's been a greater correlation between with the adopted child versus between their biological parents versus adopted parents? Well, certainly things, as we just spoke about, intelligence, emotional stability, and so on. Yeah. And that's kind of interesting that adopted children tend to be more correlated in IQ scores, yeah, with their biological parents than with their adoptive parents. Yeah. However, and tend to be more similar in terms of personality style, right? In terms of tendency to get nervous, introversion or extroversion with their biological parents. Yeah. If they were born, if both parents were kind of very introverted, kind of quiet, laid back, yeah, odds are that the adopted child will be more like the biological parents than their extroverted adoptive parents. Okay. That said, right, the data also shows, though, that there are a lot of things in which parents, right, the adoptive parents, can have a huge influence on their children. such as attitudes like a work attitude, a work ethic, values, right? Let's just say valuing spending time with the family or not. Yeah, manners, certainly religious beliefs. That's not biological as far as we've seen. That's primarily through the environment, right, where you grew up or what your parents decide they're going to do with you in terms of faith and politics, right? As far as we, at least at this point, we haven't discerned a Republican or Democrat gene. All right, it's usually what your parents kind of raised you with. So there's also evidence of a huge impact of environmental influences, the impact of parental choices. Yeah. Okay, this I think I'll skip. And finally, one of the things I just want to make a point concerning the environment. Yeah. When thinking about the interaction of environment and nature and nurture, yeah, people often think the environment has an impact upon birth and henceforth. Yeah, that's only after you leave the womb that the environment has an impact. Okay, that's kind of a very simple, almost concrete way of looking at the impact in the environment. Actually, the environment has an impact right at conception. Yeah, because once you're conceived, right, those cells which start to duplicate almost immediately from day one are in an environment, right? Now it's not someone's living room or shopping mall, right? But the environment of the womb, alrighty, of being in utero. And there's tons of things that one is exposed to, right? In it, things such as hormones, diet, right? Other chemicals, other substances, even sound, right? Stress. That's why it matters if the um, pregnant mother is in an environment of stress, right? If she's experiencing stress, that's going to be experienced by the embryo, by the fetus, and so on. Yeah, either chemically or otherwise. All righty, so from conception, the environment has an impact. Okay, and we also find that after birth, right, the environment, right, some of the things to take into account, the environment has a huge impact, right? For example, if infants are handled, right, if they're actually touched and caressed and so on by loving, nurturing parents early on versus parents who are more distant, yeah, or gosh forbid, if a child is actually kind of, you know, put into an institution, right, because the parents, in some situations, right, gave up the child. Right? And be rest assured, not all adoptive agencies are created equal. You know? I like to think most in the U.S. are pretty decent in terms of how infants and toddlers are handled. But certainly not all, as I said, not all adoption agencies are created equal. And when you think globally, yeah, infants that are given up to different groups or institutions are not all created equal. Yeah, and how well infant is handled, like literally touched and caressed and hugged and so on, right, has a huge impact on brain development. Yeah, our brains like almost need, our species as infants almost need that contact, human warmth and contact for brain development. Okay, and I think with that, that's all I have for chapter 1. Okay, a lot of stuff we covered. But with that, why don't we stop there? Okay, let me get out of this. Okay, and that's all I have for chapter 1. Very good. We went through our first chapter, went through a lot of stuff. We'll probably review this material in some form. And with that, I'll see you in our Zoom meeting. All righty? Very good. Well done. See you guys later. Bye-bye.